So, good afternoon, dear participant, on today's session on geocomputation, online GIS, and geo web services for disaster risk reduction. My name is Harish Karnatak. I am from Indian Institute of Remote Sensing, ISRO, Dehradun. So today I'll be discussing about the concept of geocomputation and methods of data access and dissemination through online data repositories and geoportal applications. I'll also brief you about the important source of data from where you can download or you can access the data either through web services API, or sometimes you can also download the physical format. I will also discuss about the important open source software tools and products which are available for you, and I will show you their hyperlink from where you can download these resources, and also some generic GIS related software also I'll be discussing about their capabilities and important features. During this session, I will switch off my video for better visibility of the content at your end, and I will deliver the session for another 40 to 50 minutes, and then I will take your questions. So I request all the participants to please keep their questions ready and post this question in our chat box of eClass platform. So let us start the session now. So first we'll try to understand the concept of geocomputation. The term geocomputation is made with the two important English term, is a one geo plus computation. So here geo refers geographical or geospatial, and computation is a computation. So we are basically combining two technologies. One is a computer technology and another is a geospatial technology for solving a specific GIS related problems. So here geocomputation term, which is basically frequently being used by the GIS professional for utilizing the computation resources to access or process the geospatial data, either it is a raster data, vector data, or some other format data. If you see typical definition of geocomputation, which is given by different researchers, is like something like this. This is the art and science of solving complex spatial problem with computers. So here the term spatial, what I'm using here, it is basically a location specific problem. So where the location specific problem, if I am trying to solve using the computation infrastructure or through the computer, then it is known as a geocomputation. The another popular definition by Ridge and Turton is the process of applying computation technology to geographical problem. Very straightforward definition. For any specific geographical problems, if I'm applying the computation technologies, and these computation technologies could be like data accessing, data processing, or data presentation. All three components we can refer it. So we can use the computation technology for all such kind of data processing, presentation, and data accessing. The computation theory of complex socio-temporal process. This is another simple definition. It says that the geocomputation is the computational theory of complex socio-temporal processes. Next definition, which is very popular in this particular domain, is a geocomputation is the way in which new computational tools and methods are used. Also fundamentally about the depiction of a spatial process. This is a little bit scientific definition where it talk about the spatial processes. So in general, in GIS courses, we are always discussing about what is the spatial process, where basically we involve geospatial data and we conclude or we derive some meaningful information out of this data for planned or informed decision making, and these decision makings are related to our geographical problems. So what we can say now, the geocomputation is a method to use computation for processing and analyzing geographical data for for information extraction and decision making. So this is a generic statement what I can make here based on the definition given by different researchers. Basically, what we do here in the geocomputation methods, we apply the computation processes for analyzing the geographical data for information extraction and decision making. Now the question is, when we do the information extraction, then for this purpose we have different methods available in GIS. We can apply these methods, and these information extraction could be sometime simple creation of the map. So when we have the satellite imagery, we have the drone imagery, what we discussed yesterday. So if you want to extract some meaningful information out of it, then we can apply some image processing techniques, or we can also do some visual interpretations and generate the information. Whatever information we generate, and these informations are basically used for the informed decision making, where the scientific or science-based plan can be built, and based on this plan we can take better decisions. In this entire process, when we have the data, we have the computer resources, and computation resources in these days, you know that we have slowly moved from simple desktop-based computers to workstation to server to today we are talking about then high performance computing clusters. We are talking about the cloud computation architectures. So these advancements are always there in the computer domain, and since in geographical domain the computation developments are directly impacting it. So here whatever developments are happening in the computer science or information technologies, these are reflecting directly in geospatial domain. Now let us try to understand data and information access from the geoportals. So you know that today what is happening, the different organizations, those are involved in the data creation or data generation process, either through some sensors like a space-based sensor like satellite, through the UAVs, ground-based sensors, or maybe sometime a traditional surveying techniques, or sometime we can also say that they also serve data like a legacy data what is available as an archive with their organizations. So when this kind of data is available in a traditional or typical environments, when we access the data, basically what we do, we access the data as a physical data. So basically from one organization to another organization, we transfer the data through some storage media. If it is a digital data, then we store into hard disk, store in DVD, CD earlier days, these days the USB disk, and there are other methods through which we basically transfer the data from one source to another source. But in the advancement of the technologies like internet, so what we have seen, these traditional methods of data sharings are slowly phasing out. So now these days people are not sharing data in the form of hard disks or in the form of CD and DVDs. The technology is going outdated. So what is happening these days? We are hosting the data into the servers, and through the servers users are basically accessing through URLs, and either through login credential or otherwise free of without any login also, they can physically download the data through the internet medium into their local computers. But now from CD, DVD to hard disk to this internet FTP based or online data hosting methods, slowly we are moving toward a next era of data access and dissemination, that is called data access through the web services or APIs. You may be knowing that the web services is a distributed computation architectures where data is hosted as a service. So you have to understand, as a service means these data sets are programmable. So I can write a program on top of this data set, I can build my analytics on top of it, and I can get the output of it. So without physical transfer of data from one source to another source, still I can do the analytics on top of this data. Another method which is very popular these days is called application programming interface or APIs. So if you recall, if you are sometime using the Google or Bing Map or ISRO Bhuvan portals, what they say that our data is available as APIs. So that means in the API, these are the basically set of programs written in a programming language, and they also have some well-defined data structure to access these data sets by the users or developers or software developers. So we'll be discussing more about this concept in coming slides, but here you have to understand the concept of web services and APIs are getting very popular these days. So why it is required? I will I will put a very important case here. For example, suppose you have a big data repositories like ISRO Bhuvan portal, where today we are hosting around 60 terabyte of data in public domain. You think about size now, 60 terabyte of data in public domain. If this complete or all 60 terabyte data is available for you to physically download into your local computer, then also you will not able to download it, because your computer, your laptop will not permit you to store 60 TB data locally into your local computers. You cannot do it. Second thing is, our computer bandwidth also will not allow us to download such huge amount of data in the local computers. And in fact, it is not required. So what this web service and API says that without physical download of the data, since data is already available on 24/7 basis in these servers, because once these organizations has made their server live, they are not going to shut down these servers in futures. So why you want to make a duplicate copy of this data? You have the 24/7 basis internet connectivity with you. Data is available in the live servers. So what you can do, you can access this data through the web service or APIs, and then you can focus on your science or your actual work rather than wasting your time in the data management. So in this architectures, what this is that once APIs are available, you develop your innovative application at your end and focus on the outcome of this data set. Now I will show you the example. I will tell you about the like a Google Earth Engine. You may be knowing about it. This particular platform was launched sometime in 2018 by the Google. Within 3-4 years of their availability in the public domain, you see the popularization of this product. In fact, in geospatial domain, everyone, all the researchers or general public or general users are using the Google Earth Engine platform these days. Why it is popular? In fact, interestingly, Google Earth Engine is not permitting you to download anything physically into your local computers. What they do, they say that you come to our cloud and run the algorithms, run the process, and get the outcome of your study as a simple JPEG image or TIFF image into local computer. That is more than sufficient for you. So here in this entire development of API-based data access or web services-based data access, the cloud-based computation architectures are getting very, very popular among the user communities. What is this cloud computations? It's basically like a server farms, and hundreds of thousands of servers hosted in the somewhere in remote locations. And then in these servers, the software, data, the computation infrastructure, network, everything is available as a service. So service means you can hire it as per your requirement, and some clouds are available free of cost, some clouds are also available on the cost basis. Some popular cloud examples are like Google Clouds. Google Earth Engine is one of the example of it. Amazon Web Services, AWS Cloud. And then we have Microsoft Cloud like Azure, you may be knowing about it. We have Google Workspace is another cloud these days is available for the small and small business organizations. There are many. So these clouds are very popular, and there are certain advantages to host data in this cloud. Basically, one is the scalability of your computation infrastructure is very high. Suppose today you need a computer with 16 GB RAM, but suddenly tomorrow, in some of your project, there is a demand to have 64 GB RAM into your computer. So without procurement of 64 GB RAM, you can still hire the 64 GB RAM for some duration, like one day or 2 days, when you require this kind of computation. Otherwise, in traditional environment, you have to purchase it, and you have to maintain this computer into your local organization, and it is a very costly affair. So business point of view also, the clouds are getting very popular. And here in the computation cloud provides the platform to serve not only data as a service, but also the infrastructure software platform as a service. So in this entire technological development, today the full GIS servers are emerging, and these GIS servers are very, very powerful servers. And these servers are written in a specific programming language, and many organizations like ISRO, NASA, ESA, or Japanese space agencies, they are providing these servers free of cost to the users organization or user segments. So what you can do in these servers, basically, they are very powerful servers, although the core software is developed by some software company or agency, but these space agencies, what they do, they basically use these servers to host their data for public access. And these servers are very powerful servers, and they have the capability to do the mapping and data visualization. So when I have the satellite imageries, I have the maps with me. So what I can do, I can visualize this data as a 2D data or as a 3D data. So when I say the 2D data, it is like a simple digital atlas. But if 3D, like a digital elevation model, is embedded with this data, so I can see the environment like augmented reality or virtual reality kind of things, where I can visualize the entire globe in the 3D domains. It's not only visualize, I can also do the mapping activity there. So I can generate the contours, I can digitize the different features, I can generate the attribute of this map on the fly. And interestingly, if this kind of features are available to you, in that case, you do not require any GIS software to be stored into your computers. What you require, simple web browsers which are more than sufficient to execute these GIS related activities if it is hosted in the GIS server. Another advantage, data services. I was talking about the API and web services. This is a very, very interesting thing. When I have the vector data with me, raster data with me, so if I publish this data as a data service for my users, so what user can do, without physical download of this data, they can run their process, they can develop their own application on top of this data. Like if it is a vector data, so they can perform the overlay analysis. If it is a raster data, so they can do the image processing or like arithmetic operations with these images. So this is the power of these servers. Data editing, if something is already available, some maps are already hosted, so you can also allow your users to do the editing or updation of your maps, because you know that many geographical features are dynamic in nature. So if I am doing any mapping exercise in 2020 or 2010, so whatever map I have created in 2010 may not be applicable as it is in 2022. So in this case, the updations are required, and these GIS servers are so powerful, they allow you to do the editing on the fly in the simple web browser environment. Another advantage in these servers are geoprocessing services. Like geoprocessing services are very, very important for the professionals or GIS professionals. Those are interested to do the analytics on this data set. So you may be knowing about the data science these days. This particular term, we are very frequently using it. So data science. So data science is very important for developing any business analytics for companies or organizations. So these servers are very, very powerful to provide you geoprocessing capability on the fly. Another advantage is a catalog. Like suppose we have hundreds or thousands or sometimes millions of maps or satellite imageries into our servers. So I can create the catalog of it, and the catalog will provide a very, very interesting platform to the user called as a clearinghouse. So they can log into the system and they can search this catalog. And it is not necessary that this catalog will host the data from a single server. It can also host our services from multiple servers distributed across the world. So if this catalog is there, then user doesn't require to visit the individual geoportals or repository of different organizations. A single platform will suffice this requirement. Simply, user can come to this catalog and can search for appropriate data. When it is available, then the catalog can redirect to the concerned server through a simple object access protocol, we call SOAP protocol or SOA architecture. You may be knowing about it if somebody is from the computer science background. So simple object access protocol is there for SOA. So in these SOA architectures, basically web services are distributed across the servers and then available to the users. In background, you can maintain your data. If it is a structured data, then you can always store into relational database management system or GeoRDBMS. Basically, if any relational database management system support GIS data types like raster and vector data types, then it is known as GeoRDBMS. If it is unstructured data, then you can go for the NoSQL environment, like you have the MongoDB, HBase, HANA kind of database, and you can store the data and you can present all the services to users through GIS servers. In this entire development, there is one organization called OGC. This is the Open Geospatial Consortium. They play a very, very important role to develop the standard for geospatial web services. You know that if a standardization organization is not there, then what will happen? The different companies will develop their own methods or own standard for data access and dissemination. And this will create a very, very big problem for the users. Because in this kind of environment, the interoperability between different data sets will not be there. So here the objective of this organization is to establish a interoperable environment for geospatial data access and dissemination. When I say that interoperable environment means they are basically like a ISO. You may be knowing about ISO. So International Standard Organization. ISO is building a standard for many things, but OGC is working in collaboration with ISO. They develop this standard for geospatial data. In geospatial data, as of today, they develop more than 60 such a standard for different activity of geospatial data access and dissemination. And their mission is a world in which everyone benefits from geographical information and service made available across any network, application, or platform. So when they say any network, application, or platform, that means they are talking about the interoperability. This is a simple architecture that they have adopted for their web service specification. As I told you, all the web services are based on service-oriented architecture called the SOA. SOA is basically implemented in GIS by OGC, and these are the typical examples. In SOA architecture, we have three important components. One is called publish, second is called bind, third is called find. So find is through catalog, bind is through the encoding methods, publish is through based on data. So like a data services, portal services, processing services, whatever your application demand, you can choose it and you can publish the data. In this architectures, what you can see, if you have the vector data, for example, this WFS is shown. This is web feature service. So when you have the vector data like a road or point, line, polygon, so this data you can publish as a WFS. Or you can also publish this as a WMS here as a port trial services. What does it mean? So WMS means this particular service will be used for data visualization purpose. And similarly, if it is a raster data, you can publish as a WCS when it is as a data as a service. If it is only for visualization, again, this will be published as a WMS. Similarly, you may be using another important data specification or standard by Google called KML, Keyhole Markup Language. Initially, it was developed by Google. Then they have submitted to OGC for their approval. It is a completely open standard for 3D visualization of geospatial data in Earth environment, like Google Earth Engine or Bing Map or ISRO Bhuvan 3D, like a CGM Globe. So all these platforms are capable to read and write this KML format so that geo-visualization in 3D format can be achieved. So this is the object. So there are many such standards. I will not go in detail because time is very limited, but as this moment, you have to understand that OGC has developed number of service standards for geospatial data and information, and these standards are adopted by different software developers or developing organizations or companies. So they are using these standards in their own software. Once they are using this, then they are able to achieve the interoperability in the data access. Here you can have a quick look of different web service specifications of OGC. First is a catalog service. Catalog is like a CS core, CSW, IBRIM, CSW 19115, 19119, and these are the some standards. This is for cataloging. Then we have for processing. Processing means like web processing services, sensor planning services, coordinate transformation services. Very important. See, when the data is created in different projection system, different datum aspirate or projection. So what this software, if CTS is implemented, so we can take care of on the fly, we can change the projection of the data so that data compatibility will come. Similarly for encoding, like in any map, when you are creating the map, so in cartography, you require at least three basic parameters. One is a scale of the map, second is a direction, third is a legend. Because whatever colors I'm presenting in the map, if legends are not properly designed, then my users will not able to read this map properly. So for this purpose, you have to present this data in a very flexible way. Sometimes the language will also come in picture. Suppose some contents are presented in English, but my users are capable to read only Hindi language. So how I can do the transformation of English content to Hindi or any other regional language? So here data encoding plays a very important role. If you read in the literature, you'll find that data encoding is very important for all the web-based applications. So same way in GIS also we practice it. There is one very important standard called the simple feature or filter encoding. We have GML and then SLD, style layer descriptor. This is a standard what we use for the presenting the legend of a GIS map. Data service, some examples are like simple feature service. This is for vector, web feed coverage service for raster, WCS transactional, again for raster data processing on the fly, sensor observation services, table join services, and web feature services. These are the example of data service. Portal services are for geovisualization. Popular are WMS and WMTS. And other service example like GeoXML, GeoRSS, Geospatial Object, OWS Common. These are the basically advanced standard for next version of your internet technology, where we are basically going to implement Web 3.0. Right now 2.0 is implemented, but this the era in future we are expecting that Web 3.0 will be in picture, where a lot of analytics can be developed on the web applications, where web will be available as a data. So this is the futures. For this purpose also OGC has developed quite interesting standards. Now we have seen basic understanding about the geocomputations. We have also discussed about some of the technologies, then some OGC standards. With this, if you move to the next phase of this presentation, is about the popular online geodata repositories which are available for you for different purposes, and they are basically following or they have adopted this standard for publishing their data into public domain. Some of these, first I will take some popular geoportals, and these are the important source of data information for you. If you take the example of Google Maps, here this is the URL. It can provide you the global satellite images and maps in 2D and 3D at street level with various applications. Similarly, from Microsoft, we have the Bing Map, and it is a global satellite image and maps, and they have very beautiful data on point of interest and roads. OpenStreet is a very interesting website. True data democracy, they have implemented the geospatial data by the public for the public. So here open and free vector data and collaborative mapping solutions are available. You can download all these vectors for entire globe without any cost. Free of cost, these things are available, and these data sets are very important for your own project and scientific study. Then we have the Wikimapia, is again a crowdsourcing approach for tagging the ground informations. ISRO Bhuvan is a very popular geoportal in India. Especially, we provide the rich contents and seamless availability of multi-temporal, multi-resolution satellite data for entire Indian regions. And in addition to that, Bhuvan also provide thematic and disaster-specific services. In coming slide, I'll be discussing more about it. Then MapMyIndia is another commercial company in India. They have very interesting rich point of interest data. Detailed maps of India are available. They provide some of their APIs free of cost to the users. Otherwise, their data is also available for on cost basis. You can purchase this data, and very interesting commercial solution. Recently, ISRO has signed a MOU with MapMyIndia. So what we do now, we are providing satellite imagery through Bhuvan, and MapMyIndia is a mapping agency. They provide their maps, and the map from MapMyIndia and satellite image from ISRO are combined together in their portals, in both the portals. And now you can do a lot of innovative applications in these websites like a Google Maps or Bing Map. And it's a true Indian version of a mapping platform is being developed now. Indian National Spatial Data Infrastructure is an initiative by Department of Science and Technology and Department of Space. So in this portal, what you can get, the metadata catalog and policy document. In fact, if you are looking for different type of maps available in India with different organizations, then you can visit this website, and this website will give you the detailed information, what kind of data, what kind of maps are available in which organization. For bioresource related contents, there are two important websites. One is called Biodiversity Information System and another called Indian Bioresource Information Network. So they have the rich data contents of Indian bioresource information, and the system in a centralized and distributed environment is available. And these two websites are hosted in IRS domain, Indian Institute of Remote Sensing, Dehradun, and we are providing a rich bioresource information on plant, flora, and fauna. Both the contents are available free of cost to the users. Recently, Department of Space, in collaboration with Central Water Commissions, has also came out with an interesting website called India Water Resource Information System. This website provides the rich data contents for water resource of India, like a groundwater and surface water information is available. So earlier it was hosted with ISRO, but now we have transferred the technology to the CWC, and it's now available in this portal called indiawrs.gov.in. National Informatics Center, NIC, under MITI, is also developing the geoportals, basically for their demographical data. So up to the census data and up to the village level are georeference, and this data is available through the bharatmap.gov.in. This is another interesting website. Still it is emerging, but looks to be interesting for the user. That's why I'm put it into my list. This is about popular website. Now come to the online geodata repositories, especially satellite imagery and thematic maps. So I have compiled this particular presentation for your benefit. What kind of data is available in which repository? Let us start from the USGS Earth Explorer. This is about the satellite imagery right now. Okay, and this is a very, very popular portal or website. It offers the latest satellite view like a Landsat, a space satellite like Corona missions, hyperspectral data from the Hyperion mission of NASA. All data sets are freely available. And in fact, if something is not available live, you can also order the archive data, and they process your order and they provide free of cost access to this data at the global level. Then Sentinel Open Hub Access Data Repository. This is one of the very, very popular satellite data repository for high resolution satellite imagery. And in public domain, the best spatial resolution which is available freely to you is a 10-meter spatial resolution, which is from this open access hub of Sentinel. They provide the Sentinel-2 high resolution latest satellite imagery of the world. And Sentinel-2 is a 10-meter resolution in red, green, blue, and near infrared band. It's a 12 spectral band range from the coastal to sphere band. And Sentinel-1 also is having C-band SAR data. So optical and microwave, both kind of data is available from this repository called Sentinel Open Access Hub. Another repository for satellite imagery is a NASA Earth Data Search, is Science Data Discovery System. This is an Earth Science Data Discovery System. And here you can get data on derived data from the biosphere, cryosphere, hydrosphere, or atmosphere. Most products come from Data and Application Center called DAC. And they also provide land cover data, is an excellent source of global land use and land cover data. It has specialized satellite derived data like permafrost and wetland types. And another URL is a NOAA Data Access Viewer. It's a source of authoritative data sets along the coast. And NOAA Data Access Viewer holds satellite area and LIDAR imagery. So LIDAR imageries are also part of this repository. And this repository is accessible through this URL, and complete global data sets are available here. 5 and 6, these are the two repositories, although they are from a commercial company called Digital Globe and Airbus. They sell the satellite imagery, but for the student community, suppose you want to learn how to do the experiment or how to work with the high resolution satellite imageries. So you can use their from the Digital Globe, they have the open data programs. For any natural disasters, they provide satellite imagery for relief in open domain under Creative Commons license. If this data is there, you can also download this data, and you can also do your own experiment with this data so that your understanding of handling high resolution satellite data will increase and you can take the benefit of it. They also provide some of the sample data of the, suppose you want to do some experiment with this data, you want understand how it looks like, how we can work with this data. So please try downloading from their sample imagery. For example, it has building footprints, elevation data, stereo and true color imageries as well. Similarly, for geo air-based defense, they have very high quality imageries there, like a Spot, Latest, Rapid Eye. These are some of the best in class satellite imageries. So you can download their sample data set from their repository. NASA Worldview is a good for downloading raw data and providing access to variety of scientific product, because many of these portals are providing this process data to the user. But NASA Worldview is another interesting repository. Suppose you want to make your career in the data processing side, so you can download the raw data and you can learn how to process the raw data and how to prepare a natural color composite or fast color composite, or how to prepare data for a specific application requirement. So this is a very interesting thing. Or sometimes if you are interested to develop some new algorithms or new method to process the raw data, raw satellite images, so it could be a very interesting source of data for you. NOAA class is a basically comprehensive large array data stewardship system, or called as a class. They have the oceanic imageries, atmospheric imageries, environment, climate data for entire globe. They provide free of cost to the user community. In this particular list, our ISRO Bhuvan portal also is there, which is a very, very important popular source of satellite imagery in India. We provide the rich contents and seamless availability of multi-temporal, multi-resolution satellite data for entire Indian regions, thematic and disaster services. This is the URL, but it is not a global service. It is only regional, India and surroundings. We provide the services, but best quality satellite imageries and best quality thematic maps are available free of cost to the user community. Then we have a JAXA's Global ALOS 3D World. This is basically from Japanese Space Agency. They have a very, very interesting mission called Advanced Land Observing Satellite, which is called Daichi, which is a L-band radar. So what they did from the radar data, so microwave data, they generate a very high quality digital surface model, and this DSM is freely available for download from their repository. Then we have the BETO missions. It offers the PROBA, the spot, vegetation and METOP as a free satellite imagery. These coarse resolution satellites carves out the vegetation patterns across the Earth's surface. Again, they have the global surveys. The coastal data from NOAA Digital Coast is another very interesting data repository, satellite data repository, which was developed to meet the unique needs of the coastal management community. And the website provides not only the coastal data, but also the tools, training, and information needed to make this data set truly useful for the users. So data they have, but in addition to that, they also provide training and tools for the user communities. Satellite land cover is a global land cover data source from Landsat, MODIS, and ABHRR. It includes vegetation, geological, agriculture, hydrological, and urban areas. Very, very important. But in addition to thematic, they provide the satellite imagery. This is about satellite imagery. We have seen the web portals, satellite imageries, or data repositories. Now I am coming to the open GIS data sources. In addition to satellite imagery, we also have a different type of thematic maps required in our studies, like a disaster management or monitoring. In this list, what I compiled, I feel the ESRI Open Data Hub looks to be one of the very interesting data repositories, where they claim that they have the 250,000 plus open data sets from over 5,000 plus organizations worldwide. And these data sets you can download as a simple Excel sheet, like a spreadsheet, KML as a SAFE file. And they also provide the APIs and OGC, WMS, GeoJSON, and Geo services for these data sets. Use data repositories, and as a student or as a researcher, you can explore their repositories. Looks to be very interesting. Natural Earth data supported by North American Cartographic Information Society. They provide the cultural, physical, and raster-based data sets. They also have ready-made MXDF QGIS file for quick map composition for you, so you can take the benefit of it. OpenStreet looks to be a very, very interesting website. This project was started sometime in 2004 by a British gentleman by Steve Coast, named as Steve Coast. So what he has done, he has developed this platform, and today it is very popular in the GIS community. Here, all the data sets and maps are created by the public, and these are freely available for public for their use. So they have the detailed free GIS data with different level of accuracy and completeness, high spatial resolution cultural vector data such as buildings, road, waterways, and like 250 plus such map features are available from this website. Then we have the NASA's Socio-Economic Data and Application Center, or we call it the CDAC. It shows human interaction with the environment. CDAC has a wide variety of course global free GIS data, like a flagship data. It's a graded population of the world. Global socioeconomic data comes from 15 different themes. Socioeconomic data includes a range of topics such as agriculture, climate, and health. Food and Agriculture Organization, FAO, they have a very interesting catalog service called GeoNetwork. This is one of the very popular catalog service for geospatial data, which is a very popular portal for free GIS data from United Nations. So the global agriculture food organizations, they have the global data sets, and they are sharing through their product called GeoNetwork. Another popular GIS data repository is Open Topography. They have the LIDAR data sets. Popularly, 90% of these data set belongs to US, Canada, Australia, Brazil, and Haiti, Mexico, and Puerto Rico. But this is a very interesting data because LIDAR data is rarely available in GIS community. If you want do some experiment with this data set, you want to understand, you want to learn the data processing, you can use this data. Then you have the UNEP Environmental Data Explorer, basically United Nations Environment Program. Under this program, they provide the data more than 500 variables such as freshwater, climate, and health. And themes include like population, forest, emissions, disasters, and GDP for spatial and non-spatial data. This is a NEO, NASA Earth Observations. They also have the 50 plus global data sets are listed here. Constant updates, they are ensuring that timely climate information of our globe, accessible in a variety of GIS format. All raster grids are like atmosphere, energy, land, life, and ocean GIS data. And TerraPopulus is another GIS data repository. It integrates census data from over 160 countries around the world. It spans up to the 6th decade of household level data, and it aggregates data from more than 80 countries. And micro and environmental data describing land cover, land use, and climates are available. And in ISRO Bhuvan also we have some GIS data. In fact, it is one of the good data repository for India, like a thematic data set including data related to natural disasters. The 6 natural disasters, like we have the flood, cyclone, drought, earthquake, landslide, and forest fire. These are the 6 natural disasters where Bhuvan is focusing, and national level assessments are available. In fact, during the time of disasters, the near real-time data is also published under this portal. How you can get access of this data? This is a typical example of Earth Explorer. So you can see here, left side, they have the data quick look or quick view system. And this side, you can search the different type of data. You can design your area of interest. You can draw the polygons here, then quickly you can search the data by different methods are available. And by the place name also you can search, because they are using the Bhuvan, the Google Maps in the background. So Google Places are there, and then you can use these place names for searching your locality, and then you can look for the available data sets. Now come to the disaster-specific geoportals. So whatever I discussed till now, it was a generic GIS data repositories, but I have also compiled a list of online data repositories which are very popular or very useful for disaster-specific studies. Let us start with the Pacific Disaster Center. They are basically providing the global data sets on natural disasters, multi-hazard warning and decision support tools. Then we have the Global Disaster Alerts and Coordination System called GDAX. They have the satellite and ground observation-based disaster early warning alerts in RSS and KML format. The Global Flood Monitoring System, or GFMS, It is an experimental system using real-time TRMM multi-satellite precipitation analysis and stream flow surface water storage inundation variables at 1 kilometer resolutions are also available. Another important online repository for disaster studies are Global Flood Detection System. They provide the near real-time flood monitoring system using the satellite imageries. You can get access of these data set through this URL. Then this is another Dartmouth Flood Observatory. It's a flood archive recorded from 1985 onward. All the flood events are archived and the spatial data sets are available in addition to their attribute data sets, like it contains like affected areas, number of people killed, number of people displaced, the cost of damage, and measure of the magnitude of the flood are also included in the flood events. So attribute data also they have collected, and they are basically building a beautiful basically archive of the flood event and of the global this flood events. Natural disaster hazards is another portal which is a multi-hazard information on various aspects such as frequency, loss of life and economy, and other informations. FRAMS or FUMS is another very popular online data repository of NASA, basically on forest fire. You know that the forest fire is a very, very serious issue for the government agencies, because during this forest fire season, there is a loss of forest resources. And interestingly, by using the thermal band of this your MODIS and VIRS satellite, so they provide real time, in fact near real time I will say, information about the active fire locations. And this data is they are updating every day around 3 o'clock into their repositories, and you can see the active fire location globally. And you can download this data as a SAFE file. You can access as a WMS. You can also download as a CSV file, as a KML file. It's freely available to the user communities. USGS earthquake data sets are also very popular in this community. They have basically installed their ground sensors for detection of the earthquake or early detection of the earthquake. They also provide this data free of cost to the user community. Global seismic hazard map are available here. NOAA WDC historical tsunami database. And from India, we have the INCOIS data center in Hyderabad, Indian National Center for Ocean Information Services. They provide the early warning system or the historical data as well on the near real-time tsunami information from our Indian Tsunami Early Warning Centers. Very interesting developments are happening there. So you can visit their website as well. MODIS fire detection data sensor is similar to the FUMS, but they provide the near real-time data with location using thermal band, and sometimes they also provide the raw data to the users so that you can still work on the advancement of the algorithm of the fire detections and can be utilized by the researchers. Lighting and atmospheric electricity data. This is another very, very important disaster which need to be studied. So the lightning data sets are available through this website at the global natural disasters. A variety of data on lightning activities such as average places, particulate cells per year are available. Similarly, for precipitation and application viewers, they provide a 30-minute interval update on probable location of landslide using landslide hazard assessment model for situational awareness. Similarly, we have the precipitation measurement missions. These data sets are available from this website, from the TRMM mission. Indian Meteorological Department also have their data repositories under the IMD website. They host the information on meteorological observations, warn against the severe weather phenomena like snow, tropical cyclone, heavy rains, dust storm, all these advisory they issues, but at the same time they also provide data to the user communities. Similarly, other websites are also listed here. So I'll be sharing all this content into the e-class, so you can refer this slide in the future. So these are 25 slides. Now come to the tools and models available in open domain for disaster analysis. These are again very specific to the disaster event, like Anuga is a model or tool available. It's a free and open source software having the capability to model the impact of hydrological disasters such as flooding, storm surge, dam break, and tsunami. You can visit their website and download the product. HACRAS is very popular in for the water resource studies or hydrological studies. It's a hydrologic engineering centers river analysis system. Is one of the widely used free open source software to model the hydraulics of water flow through natural rivers and other channels. So you can get the detail from this website and you can use this product as well. Another is the SWMM. This is the EPA stormwater management model. Is used extensively globally in the planning, analysis, and design related to stormwater runoff, combined and sanitary sewers in urban areas. This sewer studies also you can use it, and this tool is also available free of cost to the users. Another is the CAPRA. It is a probabilistic risk assessment model. It is an initiative that aims to strengthen the institutional capacity for assessing, understanding, and communicating disaster risks, with the ultimate goal of integrating disaster risk information into development policies and programs. Very popular. And the HAJUS is another product which is a nationally applicable standardized methodology that contains a model for estimating potential losses from the earthquake, flood, and hurricanes. So very specific model they develop and made available to the user segment. So TAU-DAM is a terrain analysis using digital elevation model. If you are looking for this product where you are interested to study the 3D data, especially from the digital surface model or digital elevation model, so you can explore this product called TAU-DAM. Arc Hydro Pro Tools. This is compatible with ArcGIS. Very specific plugin kind of things are available, but to run this tools, you require ArcGIS license to be available into your computers. But otherwise, the tool is free. But to run this tool, you require the ArcGIS license. GRATS is a very popular, especially for the researchers or scientists those are basically working in a high performance computing clusters where they are running the models like WRF and all. It's a very popular product called Grid Analysis and Display System. It's an interactive desktop tool that is used for easy access, manipulation, and visualization of earth science data. GRATS has been implemented worldwide on the variety of commonly used operating systems and is freely distributed over the internet. In fact, we've used this system very extensively to extract the required information for the model outputs of this scientific studies. Like a WRF output, if I have in a NetCDF format, I can run the GRATS there, and I can extract the required data or information from these products, scientific products, for my own planning and decision making. In addition to that, we also have some freely available GIS software for geographic data analysis during the disasters. I will not spend much time here. Quickly, I will run these slides because these are the very popular or generic GIS softwares. So you can explore this at your end as well. Quantum GIS, you all knows about it. Freely available is generic GIS software. Saga is very popular for scientific analysis. If you are looking for data analysis, especially for raster data, so we'll recommend for Saga. Another important product, especially for image processing related activities, called GRASS. It's a geographic resource analysis support system. So it's available now in the Windows and Linux platforms. Very, very popular scientific product. In fact, if you search for a majority of good scientific publications, people are still using the GRASS for their scientific studies. They have beautiful modules for hydrological studies and water resource related studies, and you can explore at your end. Very, very popular. Then we have ILWIS, again from ITC Netherlands. They started this product initially as a proprietary product, then free product. Now they made it as open source. It has the capability to handle vector and raster data together, and it's freely available to you. And it's a very powerful software, very good GUI, and you can learn ILWIS very quickly. Much scientific knowledge or much computer knowledge is not required. So simple knowledge, you can learn how to operate the ILWIS. GBSig is for mobile application, desktop-based application, but here you can use for the mobile as well. Map window was very old one, but still I'm keeping into my list because I feel that looks very interesting. Not many tools, but for the Windows users, sometimes looks to be lightweight and good product for simple data visualization and query. Whitebox GET, it is a open source desktop GIS and remote sensing software package for general application for geospatial analysis and data visualization. So analysis is their focus. UDIG is a user-friendly desktop internet GIS. So here whatever I was discussing about the WMS, WFS, WCS and all. So advantage of UDIG is you can call out these services together and you can build your analytics on top of the web services. This is their strength. Geoda is a free GIS software program for special data analysis, and its main functionality include the geostatistics and perform the autocorrelation, descriptive and regression analysis. Very popular for statistical analysis with the geospatial data. Landsat is another product which is again free. It has the good basically for geomorphological studies and all. For geological studies, you can also explore this product. So I think I will not go further because I think majority of things I have covered. ISRO Bhuvan is there, the next part of my presentation. So I will conclude my session here. With this, thank you very much for your very patience listening. I hope you must have noted down your questions. Although this session was not very technical session, it was a generic session for awareness about your knowledge. I hope it will be useful for you for your future studies or for future learnings, and all the content uploading into the into eClass platforms. There you can download this PDF version and you can also study it. With this, thank you very much. Please post your question now.